Before we move on to compound inequalities, let's just take another look at the simple inequalities. When we solved the simple inequalities, we said that we could have one-step, two-step, and multi-step, as well as variables on both sides. So let's just do a couple to practice. Again, our goal to solve an inequality is the same as to solve an equation to isolate the variable. When we see problems that have parentheses or like terms, simplify them first. 3 times x is 3x, and 3 times 1 is 3, and that's less than 9. We'll then add 3 to both sides. And we'll get 3x is less than 12. We'll divide by 3. And our solution is all real numbers of x that are less than 4. It does not include 4, just all numbers less than 4. Our second problem has our variable on the right, and there are some like terms. We'll start by combining the like terms. We'll now use 2 inverse operations. We'll add 4 to both sides. 16 is less than 2x. We'll divide both sides by 2. And we get 8 is less than x, which means we're going to rewrite that with the variable first. So x is greater than 8. Always writing your variable first. And those first two, again, open circle and shading. In the third problem, we see that we have variables on both sides of the inequality symbol. So we'll collect them to one side. We'll subtract 2x on both sides. That leaves me with 4x minus 1 is greater than 1. We'll now add 1 to both sides. That gives me 4x is greater than 2. And we'll divide by 4. Simplify, and we get x is greater than 1/2. Again, we're dealing with real numbers. We can get fractions and decimals as well as integers. So remembering everything we learned about equations, we're now applying to inequalities. Those were our simple inequalities. Today we're going to take a look at compound inequalities. A compound inequality is nothing more than two simple inequalities joined by the word and or. Example number 1. This is read, x is greater than or equal to -2 and x is less than 1. So when solving this, it says that x is equal to all real numbers that are greater than or equal to 2. If I read this, I could actually take this apart as 2x is greater than or equal to -2 and x is less than 1. That's written separately, and that's written together with the compound. I'm going to graph this by first finding -2 and putting a closed circle there. I'm going to then find 1 and put an open circle there. Now let me read this again. X is greater than or equal to 2 and less than 1. My solutions fall within those two boundaries. I can choose -2 and everything greater up to but not including 1. That's the n type. The n type meets in the middle. When I'm dealing with the or compound inequality, you're going to have two separate statements. We're going to graph that on the number line as well, but they're going to go in opposite directions. I have an open circle at -1. I have a closed circle at +2. Let me now shade. X is less than -1, shading everything less than, or x is greater than or equal to a +2. I always use the analogy that this is like the oars on a boat that go in opposite directions. And there you have a quick introduction to compound inequalities. So let's see about solving them. We'll try the end first. In this first problem, you're going to notice that the x is not isolated, and that's always our goal, is to isolate the variable. Since x is not isolated, I need to use inverse operations to get the variable by itself. I'm going to subtract 1 on all sides, not just the center, but on the left and on the right. This now gives me 3 is less than x, and x is less than or equal to 6. Again, a compound inequality says let's graph on the same, except I made a mistake there, that's 5, sorry. I'm going to find 3 on my number line, open circle, 5 on my number line, closed circle. This is an AND inequality. It says that x is greater than 3 and it's less than or equal to 5. An AND inequality, compound inequality, meets in the middle. Let's look at a second example. In my next one, I have 2 steps to isolate the variable. I'm first going to add 8 to both sides. That's going to give me 6 is less than 3x, which is less than 9. I now have one more step. I'm going to divide both sides by 3, and I'm going to divide and get 2. And this now says that x is greater than 2 and less than 3. And just a shading in between. That just means all those values in between make this a true statement. Let's take a look at our OR compound inequalities. In the OR compound inequalities, we're going to be looking at 2 parts. And the solution of this type will answer them separately. So I have 2x plus 3 is less than 5, or 4x minus 7 is greater than 9. Once again, let's use some inverse operations. I get x is less than 1. And then I have that OR, because I'm looking at 2 parts. I'm going to add 7 to both sides. And I'll divide by 4. And I get x is greater than 4. So in this compound inequality, once again, I'm going to graph them on the same number line. The first part of that says that x is less than 1. Shading everything that's less than 1. Or x is greater than 4. Graphing them both on the same number line, and here's another of those with the OR that tells me the solutions will go in opposite directions. Let's try one more. Let's solve them separately. We'll start by subtracting 7 on both sides. And then dividing by -2. I hope that you remember when you divide by a negative, you reverse the direction of your inequality. On to the second part. The second simple inequality of this compound says let's subtract 5. Let's divide by 3. And the second part says that x is less than -1. Time to graph. X is greater than 2. Open circle and shade everything that is greater than. or x is less than -1. Open circle and shade everything that's less. And there you have some examples of our compound inequalities, the ands and the ors. There's some homework for you to try tonight, to do a little practice. There's one last thing that we could do, and that's to test out possible solutions, and we'll look at that next time.